So now that we've gone over notes of key features, I want to actually practice one where you go through, you analyze the graph, all that good stuff. I have a graph here for you, and I want to answer a series of questions. First of all, please give me the x-intercept. The x-intercept, remember, that occurs where we touch the x-axis. So let's see where we touch the x-axis. And it was so nice that somebody already labeled the x-axis for us. So it looks like I have an x-intercept at -7. I have another at -3. I have another at 2. And I have another at 7. And now I want to know the y-intercept. Well, the y-intercept occurs where we touch the y-axis. And the y-axis we touch here. So my y-intercept is 2. Here is a question that I ask always, and I would be remiss if I didn't ask it now. Can you have more than one y-intercept? And the answer is no. Suppose I had a y-intercept here at -3, but at the same time I've got a y-intercept at, oh, my bad, that's 1. Dude. If I have a y-intercept at 1 and then a y-intercept at -3, look what's going to happen. My vertical line is going to touch both points at the same time, and that's a no-no for functions. So this graph has no y-intercept. Now the question is asking me to find g of 9. G of 9 says find y when x equals 9. So I look on my graph to where x equals 9. X equals 9 here. Let's find the point where x equals 9. Well, the point is 9, 5. So when x equals 9, y equals 5. In other words, g of 9 equals 5. So the answer is 5. When does g of x equal -2? Let's look at this one now. So they're asking me find x when y equals -2. So I'll look down here at -2. There's 1. And there's 1. So I need those x coordinates. Y equals -2 when x equals -6 and when x equals 5. Now I am asked to find g of 3. So I need to find y when x equals 3. X equals 1, 2, 3 right here. Where's my order pair? That order pair is 3, -1. In other words, g of 3 equals -1. And then when does g of x equal 2? So again, I look, there's 1 right there. Everything here is where y equals 2. There's 1 right there. So that happens when x equals -8 or x equals, +8. So those are your basics. Given the input, what's the output? What are the x-intercepts? What are the y-intercepts? Now we want to talk about the rate of change. So I have printed out another graph so that I can look at some of these and I can move this as I answer questions. On the interval -9 to -6. So let me actually draw my little barrier lines here. So from x equals -9 to x equals -6. Is the average rate of change constant or variable? Well, it's a straight line, so it's variable. Oh my goodness, it's not no, it's constant. And it's not a straight line, it's a segment, but we actually need more than that. So what I think I want to do is find my rate of change here, my Yeah. So we go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. It's constant because we have the same rate of change throughout. I could have given a numeric answer, but did they ask for a numeric answer? No, all they asked for was an explanation. Now let's look at what happens on the interval from 2 to 5. So here we are at 2, and here we are at 5. Is that rate of change constant or variable? That rate of change is variable because the rate of change changes. Well, let's see what it changes from. It changes from -1 divided by 1 to -1 divided by 2. And I could be picky here and say, make that a whole number, but all I'm looking for is something different. And I see the something different in the denominator. So immediately I know it's a different rate of change. So please look at these two. A constant rate of change has the same slope all the way through. A variable rate of change will change. So that takes care of 7 and 8. Find the slope on the interval from -9 to -6. Well, when I go from -9, from x equals -9 to x equals -6, I'm going to go down 1, 2, 3, 4, 5, 6. Then I'm going to go to the right 1, 2, 3. So my slope will be -9 divided by 6. No, just kidding. Divided by 3, which equals -3. Robodeer, that's great and all, but what if I need the slope formula? Well, let's look at the slope formula then. The slope formula takes the ordered pair -9, 4 to -6, -2. So my slope equals the difference in the y's divided by the difference in the x's, and I get 6 divided by -3, which is -2. Boy, I did something wrong. I know what I did wrong. This is supposed to be -6 divided by -3. My bad, which is -2. So either way, I will have a slope of -2. Using the slope formula, I find the slope is -2. Using the rise over run, which I need to do again because I screwed that up so badly. Bruh. I'm going to go down 1, 2, 3, 4, 5, 6. So my rise is -6. And then my run 1, 2, 3. So -6 divided by 3. And I find my rate of change is -2. Hopefully, I sort of redeemed myself there, but if I screwed you up, I'm really sorry. Now let's look at the average rate of change from x equals 2 to x equals 5. So here's x equals 2, here's x equals 5. We're going to go down 2 to the right 3. So I should call it the rate of change, I guess, equals -2 divided by 3. Let's do that here. And for those of you that don't like rising and running, who prefer ordered pairs, let's find the slope from the ordered pair 2, 0, right? 2, nowhere 0, and then 5, -2. So my slope will be 0 minus -2 divided by 2 minus 5. That's 2 divided by -3, which is -2/3. And you know what? I could have kept this as slope. Oh my gosh, what a teachable moment for me. And then I could actually take it to you. Remember, slope is a measurement that works with a straight segment, which is what we have here. So I'm allowed to say slope. But from 2 to 5, this is a curve. Slope is not allowed in my vocabulary there because those aren't straight segments, they're curves. So in order to talk about any change there, it must be the rate of change. Good lesson for me, and therefore a good lesson for you. Now I'm asked to find the domain and the range. Remember, the domain is how far to the left does it go versus how far to the right does it go. So let's look at our graph here. I need a different color. Domain. How far to the left does this thing go? Well, it goes as far as -9. How far to the right does this thing go? Well, it looks like it's going to stop here. But see that arrow? That arrow says even though I'm going up, I'm still going to the right. So it looks like we're going to go to infinity. So my domain goes from -9, and I can equal -9 because it's a closed circle, and it goes to infinity. I cannot equal infinity, so I leave that as an open circle, or as strictly is less than. And again, I'm going to bring in interval notation. My interval goes from -9 to infinity. I can include -9, therefore I use a bracket. I cannot include infinity because I can never touch infinity, so I'm going to put a right parenthesis. So let me put both of these answers down here for you to see. My domain is -9 is less than or equal to x is less than infinity. Or for interval notation, we're going to go from -9 inclusive to infinity exclusive. And I kind of liked using the lines there to work with domain. I believe I shall do the same for range. So remember, the range is the set of y values. How low does this thing go versus how high does this thing go? Well, my lowest point appears to be -2, and we touch the -2. And the highest that this goes is, forever. So we're going to go to infinity. So my range covers -2, which we can equal, and these are the y coordinates we're dealing with here. And we can go to infinity, which we do not equal. You can never touch infinity. So in interval notation, we're going to go from -2 inclusive to infinity exclusive. So my range, remember, deals with my possible values of y. So there we are with my domain, and there we are with my range. So once we've covered domain and range, let's talk about intervals of increasing and decreasing. Look at what's happening from -6 to 0. So I can draw my lines, but sometimes it's so much easier. I'm going to go from -6 to 0. I don't want to look at anything else. Everything else is noise. What is happening to the graph? Well, it starts low and it's working its way up. So guess what? It is increasing. What's happening from x equals 0 to x equals 5? So x equals 0 is this vertical line. X equals 5 is that vertical line. What's happening to the graph? It's going down. Therefore, it is decreasing. Remember, you always look from left to right. From left to right, the y coordinate's going up. The graph is going up. From 0 to 5, look at the y coordinate. It's going down. The graph is decreasing. Now let's look at the interval from 5 to infinity. So from 5 to infinity, we are increasing. And now no more increasing. Find the average rate of change from x equals negative 9 to x equals 7. So let's look at x equals negative 9, which is this point here. And let's go to x equals negative 7, which is here. What is my rate of change? Well, we're going to go down 1, 2, 3, 4. Then we're going to go to the right 2. So we are taking negative 4 divided by 2. Negative 4 divided by 2. So my average rate of change is negative 2, which it makes sense because it's within this other interval that I had, and we see that it's a straight segment. Now I need to find the average rate of change from x equals 3 to x equals 8. So from x equals 3, we are here. And when x equals 8, we are here. So what is my rise? I rise up 1, 2, 3, and then I run 1, 2, 3, 4, 5. So my average rate of change will be 3 divided by 5. Rise over run. And as x goes to infinity on the right side, what does g of x do? Well, let's see. As x goes up, as x goes to the right, as we move to the right, we're also moving up. So it looks like g of x also goes to infinity. And again, I went over this in the notes, but I just want to make sure that you understand how intercepts work, how rates of change work, how domain works, how range works. Those are basically the general ideas. And I want to make sure you understand this completely because in our next section of this concept, we're going to apply meaning to them, i.e. word problems. Ha, maniacal laugh.